going to talk about p-values. In our last lesson, we did hypothesis testing with means. Today, we're going to talk about what a p-value is. I think the easiest thing to do is to go through one hypothesis testing problem and then go back up and talk about these pieces. So we're going to do an example of a hypothesis test that we learned the other day, and then we're going to go through it, and then I'm going to talk to you about what the p-value is. Okay, a researcher wishes to test the claim that the cost of tuition and fees at a four-year public college is greater than $5,700. This is like FCC. She selects a random sample of 36 four-year public colleges and found the mean to be $5,950. Okay. Well, I guess that isn't FCC because it's a four-year public college. So let's say that the mean right now is $5,700, and she thinks that it is more expensive than that and finds it to be greater. Okay, she's saying that she thinks that it's greater than. So researcher thinks it's greater than 5,700, so she's going to do a hypothesis test on that. So step one, hoe and haw, we did. Step two, put your hoe in the center, that's what it is now, and you think it's greater, so you shade right, and then the alpha level is 0.05. So if you're never given an alpha level, always default to 5%. Okay, so we have all of that. Now we're going to find our t. So our 36, you can either go to the t-chart and use a degrees of freedom of 35. So it's in between 35 and 40. So I would do 40 because it's closer to 40 than it is closer to 30. So I'm going to go to 40 right here. And 5%. And we get 1684. Remember, you can also use that inverse t function, which I'm okay with. So we get 1.684. All right, so then we're going to calculate our test value. Our test value is the one that we test to see where it lands on the curve. That's why it's called a test value. Remember, this from the other day is called our critical value. That's where the shading starts. So our test value is our sample mean of 5,950. So it is greater, but how much greater? 5,700 over standard deviation of 659 divided by the square root of 36. Okay, so we're going to go to our calculator. I want everybody using their calculators for this. We're going to go to stat, test, t-test. And we type in 5,700, and the sample mean was 5,950. The standard deviation was 659. I'm going to have to check that. 659 and 5,950, okay. The sample size, 36, and it was a greater than test. Remember, always look at your Haas symbol. Okay, we hit enter. And we get a t of 2.27. And then this is what we're going to talk about today, this p-value. I had you write it down the other day, but you didn't know what it was. So this p-value is 0.014. All right, so we go back to here. So I think it was 2.27. The p-value was 0.014. Let me check and make see that's right, 2.27 and 0.145. Okay. Alrighty, so now let's take a look and see when we land. All right, so 2.27. 2.27 lands in the shaded, so we're going to reject. Okay, so let's talk about what this 0.145 means, this p-value. All right, so you are landing right around here. This area here is just the p-value. So all p-value is the tail area of your test value. That's all it is. All right, so let me make this big so you can I'm going to exaggerate it. Okay, so there's your 5,700 down here. Okay, so we got a critical value of, I'm going to exaggerate and put that in, 684. That is 0.05. That red area is 5%. Okay, then we went and got our 2.27. We landed in shaded, so we're going to reject, right? Because we're landing in the shaded, so we definitely are going to reject. This area, and I've exaggerated, like I said, is this area. So the p-value is your tail area to it. So let's take a look at this. We can now do our rejecting or failing to rejecting in two different ways. We have a critical value where the shading starts. If your test value is greater than that, further out in the curve, if you're on the negative side, it would be less than, but let's say further out on the curve. If this is further out on the curve, it's going to land in the shaded and you're going to reject. Now, let's take a look at this. This whole red area is an alpha of 5%. That means the total shaded area from the critical value on is 5%. Our test value at 2.27 had a shaded area of 1%. So this is just another way. You're not going to get a different answer. This is just another method of looking at and whether you're going to reject or not. So since this area is less than this area, you have to be further out in the curve. So you have to reject. So if your p-value is less than your alpha, then you reject. Okay, so two ways to do a problem now. If your test value lands in shaded, you reject, or if that p-value, that tail area, is less than your alpha, then you reject. Okay, all right, so let's go back up there and let's write our sentences first. Oopsie daisy. Okay, so let me do a text box and we're going to reject and we're going to say, there is evidence to suggest that the mean cost of tuition is not 5,700, or you can even say it's greater than it, that there is actually evidence to say that it's greater than it. Now, new sentence. So you have two sentences to write. Usually we write our p-value sentence first. I'm going to put that one up here. Okay, so there's a template on the other page. I'm going to get on the page above this that I'm going to go over, but here's what a p-value is. There is a, and then we're going to change this to a percent. Take your p-value and change it to a percent. 1 point, oops, where am I going? Is a 1.45% chance of getting the same sample mean of 59.50 again or more extreme based on a true mean of 5,700. And you have a template open up 5,700 and 5,700. Okay, so there's my p-value sentence. So now you're going to have two sentences you're responsible for. Okay, let's read this p-value sentence over again. So there is a 1.45% chance. I just took my p-value and changed it. I took my p-value, changed it to a percent. Okay, so here's what the p-value is. It's just this tail area. So what it's really saying is if you have a curve and you have a hose set at 5,700 and you got 5,950, which is what we got, that is its tail area. So your p-value statement is there's a 1.45% chance of getting 5,950 again or more extreme, got a little typo there, based on a true mean of 5,700. So this percent of getting this based on this, right? And up above is a template sentence for you. So let's go up above and talk about what I have up here for you. Okay, so now you know two ways to reject. So you can reject if your test value is greater than your critical value. And we're talking about it in a sense of absolute value, because if you're on the negative side, it's actually less. But if your absolute value of your test value is greater than, that's if you land in shaded, you're going to reject. And then another method, you're never going to get a different answer. It's always going to give you the same. If your p-value is less than your alpha, your total alpha, then you reject. And we have a little statement that we say, if p is low, reject the hoe. So if p is low, reject the hoe. Okay, and you'll always remember that. So if p is low, reject the hoe. Or if it lands in shaded, your test value lands in shaded. If it's further out along the line than the critical value, you reject. These are not two different answers. You're not going to get reject for one and not the other. You're going to get the same one. It's two different methods. You need to learn how to do both ways. Here is the template for the sentence that I just typed. We'll practice it again. And I'll go over this on the next problem. Okay, so example 2. A researcher claims that the average wind speed in a certain city is 8 miles per hour. All right. A sample of 32 days have an average of 8.2 miles per hour. Okay, so this is still going to be 8. The standard deviation of the population is 0.6. At an alpha of 5%, is there enough evidence to reject the claim? Okay, so he says that it is 8. I don't see any indication of less than or greater than, so I'm going to do a not equal to. Is the sample greater than? Yes, but there is no indication that I want a less than or greater than. So I'm going to draw my curve here, and then I'm going to shade my left tail and my right tail. I'm going to center it at 8. Now the alpha is 5%, and I have to separate it because it's two-tailed. So that means I'm going to be looking up at 0.25. The degrees of freedom is 31. So I'm going to go to 31, or 30 is my closest. And I'm going to go to 0.25, so 2.042. And that can be negative or positive. Okay, so let's just label these. This is your critical value. That's where the shading starts. Your alpha level is your total shaded area. And then here you divided it because you had 2 areas that needed to be shaded. All right, so let's hit our test value. Or test, remember, I've been calling it a test value. You can also call it a test statistic. So our sample mean is 8.2 minus 8 over standard deviation is 0.6 divided by the square root of 32. We go to our calculator, stat test, t-test, 8, sample mean was 8.2, standard deviation was 0.6, 0.9. The sample size was 32, and it was a not equal to test on this one. Okay, we hit calculate, and we got 1.88 with a p-value of 0.068. Right, so 1.88 with a p-value of 0.068. All right, so let's talk about it in our test value way. Oops, sorry about that. All right, so 1.88 is right here. It's going to land in white, so we're going to fail to reject. You must know both methods because I'm going to give you a couple questions where I'm just going to give you the p-value and you have to tell me. Okay, now this p-value, this 1.88, you take it and you double it. And the calculator automatically does it so that you can compare it to 0.05 instead of comparing it to 0.25. On each one of these tails, the area is really 0.068 divided by 2. So instead of you having to do any work, what they do is they take the p-value and double it so that you can just use it to compare to the total alpha. Okay, so the p-value was 0.068. That is greater than your alpha, so you fail to reject that way too. So you're going to fail to reject. I'm going to leave room for my sentences. Okay, so either way, P is not low. So if P is lower than your alpha, you reject. So we're not going to reject. So if P is low, you reject your hoe. So if P is lower than your alpha, then you reject. All right, so two ways to do it now. If your critical lands in shaded, you reject. This is lands in white, so we don't. And then if the p-value is lower than the alpha, it is not, so we don't reject. Okay, so we're going to write two sentences now. And the first sentence is, there is not enough. Oh, well, let's write our p-value sentences. There is a, then I'm going to get to a 6.8% chance of getting the same sample mean of, and the sample mean was 8.2 miles per hour. Again, or more extreme. I have a template on the other page for you to do. Again, or more extreme based on a true mean of 8 miles per hour. Okay, so follow your template. That's your p-value sentence. Okay, so you fail to reject because it's bigger than 5%. And then you fail to reject. There is not enough evidence to suggest that the true mean is other than or not other than. You can say other than, or you can say or not 8 miles per hour. We have no evidence to suggest it's anything else other than 8 miles per hour. So there's not enough evidence. Okay, so that's your p-value. So let me show you something about that two-tailed test and what I was talking about up here about this area. So if I go to the graphing calculator, and right now it's a two-tailed test. If I change this to a one-tailed test, so I'm going to go in and do stat test, t-test, and I'm going to change this just to a greater than test, leaving everything the same and changing it to a greater than. Okay, so the p-value was 0.068. So I'm going to divide by 2. It's going to be 0.034. Watch what happens. What it does is all the less than, greater than, not equal to does. This is the same. It's actually 1.89. I rounded incorrectly. And then the p-values, look, 0.034. Everything else is the same. I didn't change anything in this problem. So if I look at it, that 1 point, that should be a 9. Let me fix that because, that's going to bother me that I didn't round correctly. That should be a 9. Sorry. So what that is, this is 0.034 on this side, and then 0.034 on this side. That's where they're getting the 0.068. What the calculator does for you, instead of you having to divide the alpha, it doubles the p-value. So all you ever have to do is look at the 0.068, the p-value, and the total alpha. Okay, we failed to reject because this was greater than this. On the one up above, we rejected because our p was less than the alpha. So if p is low, reject the hoe. If p is lower than your alpha, reject the hoe. So if p is low, reject the hoe. Okay, so another thing up here that I just want to go over real quick was this calculator function. So calculator. So if I go to second bars and I type in this function here. It gives me the tail area, so it does a tail area for me. Some of you may want to use this. Some of you may want to keep these notes. If you take another stat class, it may be useful to you. So the lower is going to be your test value, and then you're going to put in infinity, and then your degrees of freedom. So let's say on this problem here, it was the test value was 2.27. So the test value came out to be 2.27. So I can go to my calculator. I can go to second bars. And you don't think you really need this, but I kind of show it to you just in case. And my lower, it was 2.27. My upper is just infinity. I'm just going to do that, one with a whole bunch of zeros. Even a 3 zeros is fine, 1,000 is fine. And then whatever the degrees of freedom was. Forgot the degrees of freedom. 35. Sample size is 36. Okay, and I hit paste. And voila, there's the p-value. So that's a way to do the p-value too. Okay, if it was on that other one, second bars, TCDF, you have to type it in, and then you're going to have to double it. So this is not really that useful. I would just do the stat test, and it automatically gives it to you. But I'm just giving you another way of showing you how to use the TCDF to get a tail area. So let's say you had a negative. Let's say your test value came out to be, like you did a test, and your HO was 10 and you came out and your test value was 1.86 negative. So the lower is negative infinity. The upper is the 1.86, negative 1.86. So lower would be negative infinity. Upper would be negative 1.86, and it's going to calculate this area. So from infinity to the test value, and then you would type in your degrees of freedom, and it would give you this p-value. It finds from here to here. So if you're on the positive side, 1.86, this is your lower, and your upper is infinity. Don't worry too much if you don't want to use that. That's fine. You don't have to, because if it's a two-tailed test, then you're going to have to do it by yourself and multiply by 2. So I strongly, and I'm only going over this with you for college sake, I strongly suggest using your stat tests, and then it'll be fine that way if you just use your stat tests. Oopsie daisy. Okay, well that's p-values. So I added another step there and one more sentence. Now you have all your steps of hypothesis testing. You can use the p-value method, or you can use the critical value method to reject or fail to reject. You must know both. You will have different questions on the test asking those different types.